Hey guys, I know that you are prepping for the end of the semester, and so I want to work through a review with you guys to make sure that you can do very well on this. So the first question is find the equation of the line passing through 3, 2 and perpendicular to the line given. The only thing that we need from this equation is this slope. So we're going to write down m equals 5/3. Remember that the perpendicular slope is going to be the negative reciprocal of the slope that we're given. Now that we have dealt with that, we are not going to use this equation anymore. So don't get confused by the fact that it's still there. Now we have a point and the slope that we need. So we're going to do our y equals mx plus b. We're going to plug in this perpendicular slope here for m. We're going to plug in 3 for x, and then we're going to plug in 2 for y. So our equation is going to look like this. Now we just have to multiply. It's going to be negative 9/5 plus b. And then we're going to add over the 9/5. So we're going to have 2 plus 9/5 equals b. In order to multiply this, to add these together, we have to get a common denominator. So we are going to multiply 2 by 5/5. And this is really like 2/1. So it's going to be 10/5 plus 9/5 equals b. So we're going to have 19/5 equals b. To finish out this problem, we would now plug in our corresponding slope, which is here, and our y-intercept, which is here, to get our final equation. So it's going to be y equals negative 3/5 x plus 19/5. And that is your answer. Number 2, we're just going to simplify this. And we can distribute the first term to both terms in the second set of parentheses. Then we're going to distribute the second term to both sets in the second parentheses. This acronym is also called FOIL, with first, outer, inner, last. So the product of the first two terms is 6t squared. The product of our outer terms is 8t. The product of our inner terms is negative 15t, and the product of our last terms is negative 20. We can go ahead and combine these two. 8 plus 15 is 23. So we'll get 6t squared. Oh, not 23. It's going to be negative 7t minus 20. Number 3, the directions are still to simplify. Here, we're going to take this monomial and we are going to distribute it to both of these terms. Now, I'm just going to point out, whenever we don't have a visible exponent, that exponent is 1. That's going to be important because when we multiply exponents, when we multiply bases, the same bases, we add their exponents. So we are going to go through and multiply each of these together. 8 times 3 is 24. X cubed times x squared is x to the 5th. And then that y is just going to hang out there with it. Now, as we distribute 8x cubed to this term, we're going to have 8 times negative 4, that's negative 32. Then x cubed times x to the first is x to the 4th, and then we're going to have y to the first times y squared, which is y cubed. So this is our final answer here. This is a rational expression. In order to add these or subtract them, we are going to have to factor the right side of the denominator over here. And then we are going to get a common denominator, which will allow us to subtract the numerators. So in order to solve this, we are going to set up what I like to call the X game. The X game simply multiplies 2 times 3, and we're going to write that product up here. And then we're going to write our middle B term at the bottom. So what we are looking for are factors of 6, that is, two numbers that multiply together to give us 6, that will add together to give us 5. Let's list out the factors of 6. So here we're going to have 2 times 3 is going to be the right combination so that we can factor this. I like to use the bottoms up method here, so I'm going to show you how to do that. We're going to write our set of parentheses here using the two numbers that we just found. Since we have a 2 out front we're just going to divide both of these terms here by 2 and 2. When they divide evenly, we're going to simplify them. So this one, 2 divided by 2 is just 1. So this set of parentheses is going to be x plus 1. Since this set is not an even number, what we can do is rewrite this 2 in front of our x. So it's going to look like this. So now this is the new denominator for our second fraction over here. Let's rewrite this. We're going to have 3 over 2x plus 3 minus 2 over x plus 1 times 2x plus 3. In our denominators, you can see that they both share this term, but this fraction is missing this term. So what we have to do is multiply this fraction by x plus 1 over x plus 1. Now, we don't have to FOIL the denominator. We can just leave it as is, but we are going to distribute these terms to the 3. So we're going to have 3x plus 3 minus 2. And since we have the same denominator, we can go ahead and just write it as a single denominator. Now we can combine these two terms up here. So we're going to have 3x plus 1 over x plus 1 times 2x plus 3, and that's going to be our entire answer. Number 5. Here we have two rational expressions that are divided. The first rational expression is nothing to simplify. So we're going to go through and do the same thing, play the x game with this second fraction here. So just a reminder, we have to multiply these two terms, and that's going to be the number at the top. Then we're going to write our 19 at the bottom. Now we need factors of 18 that will add to 19. And right off the bat, we get the answer. So what we're going to do is write our factors using the numbers that we just got, and then we're going to divide by 3. Neither of these, oh, just kidding. 18 does divide by 3, so that's going to be 6. But this one does not, so we're going to write that 3 in front of our x. So this is our new denominator. Let's go ahead and rewrite this. We have 6 over x plus 6 divided by 2 over 3x plus 1 and x plus 6. Similarly to the last one, you can see that both of these are in the same spot, but since we're dividing, we actually don't have to worry about making them the same denominator. Here we're going to do the keep, change, flip. That's where we keep the first term. We're going to change our sign to multiplication, and then we are going to flip our entire last fraction. So this is what it's going to look like. Now we can cross simplify. Any terms that you see that are similar between the top on the right and bottom on the left, or top on the left, bottom on the right, we can cancel and simplify. So this is simply going to be x times 3x plus 1 over 2. Okay, just kidding. I don't know where I got the x from. That is most definitely a 6. So this is going to look a little bit different. We're going to have our 6 over here, and then we can actually simplify this one more step. So our final answer is going to be the 3 distributed in 9x plus 3. There's a lot going on with this particular problem. So we're going to have to factor 3 sets of quadratics or cubics here. This is a linear term, so we don't have to factor that at all. This is a cubic term, and there's a specific formula to use for this one. This is a quadratic, and this is a difference of squares, and this is going to be another x game. So let's go ahead and work all 3 of these out. 27x cubed plus 8. We're going to have 9x squared minus 4, and then we're going to have 3x squared minus 14x plus 8. So before we address the first two, I want to go ahead and work out the last one since that's the one that we were already working on. We're going to have 3 times 8. That's going to be 24. We need factors of 24 that sum to negative 14. So we have 1 and 24, 2 and 12. And these are going to be the two factors that work. Both of them have to be negative because we have a positive product and a negative sum. So here we're going to do the bottoms up method, x minus 2 and x minus 12, and then we are going to divide by 3. That end result is going to be 3x minus 2 and x minus 4. So this right here is how we rewrite the bottom side, our denominator of this fraction. Okay, now let's work through the first one. We have 27x cubed plus 8. This is called a sum of cubes, and there's a specific formula for it. So this is the formula. Now, before you think that this is going to be something extremely difficult, it's not really. Okay, I'm going to explain it to you, and I hope that this is going to help you. 27x cubed is in the same position as our a cubed. So what we can do is say a cubed equals 27x cubed. And what we want to do is solve for a. So let's take the cube root of both sides. The cube root of a cubed is just a. The cube root of 27 is just 3, and the cube root of x cubed is just x. That means that a is 3x. And that means that everywhere that there's an a in my formula, I can just write a 3x. Now we're going to apply the same thing for our b term here. So we have 8, and that's in the position of our b cubed. So we're going to say b cubed equals 8. And in order to solve for b, we're just going to take the cube root of both sides. The cube root of b cubed is just b, and the cube root of 8 is 2. That means that I can take 2 and replace it everywhere that there is a b in my formula. Now that we've established that, let's go ahead and rewrite this. So this is going to be, we're going to replace a with 3x, and we're going to replace our b with 2. You'll notice that I put parentheses around every term I plugged in. I did that on purpose because sometimes we have negative numbers, and it's definitely helpful to keep them separated. Let's go ahead and simplify inside of the parentheses. So we have 3x plus 2 out front. This squared term applies to both terms inside. So this is going to be 9x squared. 3x times 2 is negative 6x, and then we're going to have 2 squared, which is 4. So this is now the answer that's going to go in place of our unfactored cubic term. Okay, it's going to go down here. Lastly, we have the difference of squares here. Difference of squares also has a specific formula. And we're actually going to do the same thing. So a squared equals 9x squared. And then we can just take the square root of both sides. So a is 3x. And everywhere that there is an a in our formula, we're going to put a 3x. And then we have b squared equals 4, because we have 4 in the position of our b squared. In order to solve for b, we're just going to take the square root of both sides, and that means that b is going to be equal to 2. We can replace every b in our equation with a 2. So this is going to be 3x plus 2 and 3x minus 2. This is going to be what we're going to replace our difference of squares with in our regular equation. Okay, let's go ahead and rewrite this. Okay, so let's go over this. I just rewrote our x minus 4 term because that one is going to remain the same. Our sum of cubes here became this factored expression here, which is right there. Then we had our difference of squares, which factored to this, so I rewrote that here. Then we had our regular x-game polynomial, which became this, and I rewrote that down here. Now we can cross simplify. So if there are any shared factors diagonally, then we can go ahead and eliminate those. So I can see an x minus 4 here, and that's just going to cancel out there. We have a 3x plus 2 here, and we also have a 3x minus 2. So our final answer, since everything canceled out of the numerator, is going to be just a 1 over 9x squared minus 6x plus 4. Number 7, this is called a complex fraction, and really this is two problems in one. First, we are going to work through this denominator completely separately, and that way we can organize our work. Then we'll come back to the original problem. So in order to do the denominator, we have a difference of squares here, and that's going to factor to r plus 2, r minus 2. Our numerator is still 5r, and we are adding 7 over r plus 2. You can see here that r plus 2 is included in both, but we need the denominators to be the same. So what we're going to do is multiply the right side here by r minus 2 over r minus 2. So since our denominators are now the same, we can go ahead and distribute this 7 and combine like terms. So 5r plus 7r is going to be 12r. And 7 times negative 2 is negative 14, and we can just go ahead and write the r plus 2, r minus 2. So this is the final factored expression just for our denominator, and let's go through and solve the rest of the problem now. I prefer to write these as sentences versus complex fractions because they just look really intimidating when they're stacked up like that. So what I'm going to do is write the numerator up here as 2 over r plus 2, and then I'm going to write the division symbol like this, and then write down our factored expression, our factored total denominator here. Okay. So this is going to become a keep, change, flip situation. We're going to keep the first term. We're going to change this to multiplication, and then we are going to flip this whole thing. So we're going to have 2 over r plus 2 times r plus 2, r minus 2 over 12r minus 14. Now we can cross simplify. So if you see any shared terms diagonally, we can go ahead and cross those out. Now let's take a look here. We do have a 2, and we have a 12 and a 14. So we can actually divide all of these terms by 2. That's going to make this top left a 1, because 2 divided by 2 is 1. It's going to make this a 6r, and it's going to be a 7 here. So in our numerator, we're going to have 1 times r minus 2, and in our denominator, we're going to have 6r minus 7. And that is our final answer. When we are dividing a multi-polynomial by, well, that's redundant, but a polynomial by a monomial, we can go ahead and separate each term individually. So this is going to be 2x to the 5th over 2x squared minus 4x cubed over 2x squared minus 3x squared over 2x squared. When we are looking at each term individually, we're going to go ahead and simplify the coefficients. So 2 divided by 2 is just 1, 4 divided by 2 is 2, and then 3 halves is not going to change. Now we can address our exponents. Whenever we are dividing the same bases, we're going to subtract their exponents. So this entire term is going to turn into simply x cubed. 5 minus 2 is 3. Now we're going to take our coefficient, rewrite that. We have x cubed divided by x squared, which is just going to be x. Next, we have x squared over x squared, and those are going to cancel. So this is going to be just negative 3 halves. And that is our final answer. Number 9, we're going to do some polynomial long division. And I really enjoy teaching this because I teach it a different way where we separate the work from the actual division, and it makes it a lot easier to understand. So what we're going to do is we are going to look at this outer term only, okay, 2y, and we are going to ask ourselves what times 2y is 8y cubed. So the way to figure that out, we're going to say 2y times something is 8 times y times y times y. You can see over here that we already have a 2 and a y. So we know that 2 times 4 is going to give us 8, but we can't really tell over here what we're going to need. We already have one y accounted for, so we're going to need 2 more. That means that 4y squared is going to go on the top. So now this is where a lot of students get mixed up. We are now going to take the number that we just got, multiply it by this whole binomial, and then subtract the result. And this is where I like to do this over to the side. So we are going to get 4y squared times 2y plus 3. After we distribute 4y squared, that's going to be 8y cubed plus 12y squared. So we are now going to subtract this result. Just like in standard division, we are going to bring down that 17y when we're done. We do have to distribute this negative because we are subtracting the entire quantity. So when we have 8y cubed minus 8y cubed, that's going to cancel. Then we have 18y squared minus 12y squared, and that result is going to be 6y squared. Now let's bring down our 17y. We're going to ask ourselves the same question, what times 2y is going to give us 6y squared? So that answer is going to be 3y. Now we're going to take this, multiply it by the entire outside, and subtract the result. We're going to distribute that 3y to get 6y squared plus 9y. And again, this is where we are going to go through and subtract the whole thing. Then we're going to distribute that negative, and we're going to get 17 minus 9y. That's going to be 8y. Then we will bring down our 14. So what times 2y is going to give us 8y? It's going to be 4. So we're going to do plus 4 here. Now we are going to take this term, multiply it by the outside, and subtract our result. We're going to distribute this 4, which is going to be 8y plus 12. Now we're going to subtract 8y plus 12. We can distribute this exponent, or not this exponent, that's negative, and we're going to have 14 minus 12, which is 2. The way that you write your remainder is the remainder portion over this part out here, the 2y plus 3. So your final answer for this will be this entire thing up here. This is the cubic polynomial, and the way that we solve this is factoring by grouping. We are going to group together the first 2 terms and the last 2 terms, and we're going to look to see what they have in common. Between 2p cubed and negative 3p squared, they each have 2 p's that we can go ahead and factor out. When we take out a 2p from 2p cubed 2p squared, sorry. Not, okay, hold on, sorry. Okay, they each have 2p's, that's p squared. So we're going to have 2p left over minus 3. Between 8p and negative 12, they each have a 4 that we can take out. So this is going to be 2p minus 3. When you do this, these should match every single time. If they don't, you've done something wrong or it doesn't factor this way. Since we have 2p minus 3 in both of these terms, we can factor it out front and we can write 2p minus 3. And then we write the remaining terms, which is p squared plus 4 inside the other set of parentheses. And this is our final answer. The speed of the current of a creek is 5 miles per hour. If a boat travels 6 miles upstream in the same amount of time it takes to travel 10 miles downstream, what is the speed of the boat in still water? For this equation, or for this problem, we're going to use d equals r times t. Now, we do know that they traveled in the same amount of time, and we do have upstream and downstream. So let's go ahead and set this up. Since t is the same in both, we're going to divide both sides by r. So t is going to be the distance divided by the rate. The upstream speed is going to be slower because that's going against the current. So upstream is going to be the rate minus 5. Similarly, downstream is going to be faster because it's going with the current. So that's going to be r plus 5. It's going to go much faster there. Okay, so now that we have that, we know that the boat is traveling 6 miles upstream. So we're going to have the distance as 6, and the rate is going to be r minus 5. And since the time is the same, we can go ahead and set that equal to 10 miles downstream over r plus 5. The way to solve this is to cross multiply. So we are going to end up with 6 times r plus 5, and that comes from this way here. Then we're going to have equals the multiplication of these two, which is going to be 10 times r minus 5. Now we are going to distribute both terms, and we're going to have 6r plus 30 equals 10r minus 50. We're going to combine like terms here, and at the same time we can go ahead and add 50 over. Then we can have 80 equals 4r, which means that r is equal to 20. So for the interpretation, r up here is the speed in still water, and we just found out that r is 20. So the rate of the speed of the boat in still water is 20 miles per hour. Let's work through a mixed rate problem. So it takes Joey 10 hours to complete a job, so his rate is going to be 1 job for every 10 hours. Fred can complete the same job in 6 hours. So what we're going to do is add those together. We can go ahead and get a common denominator here, so it's going to be 3 over 30 plus 5 over 30, which works out to be 8 over 30, and that simplifies to 4 over 15ths. And this is 4 jobs in 15 hours. Since we want to know how many jobs happen, or I'm sorry, 4/15ths of a job in an hour, but we want to know how many hours it will take them per job. So we can just find the reciprocal. We're just going to flip this around. And that means that this will be 15/4. And that works out to be 3.75 hours. Now, 0.75 of an hour is 45 minutes, and you can find that by multiplying 0.75 times 60, but this is going to be 3 hours and 45 minutes if they work together. We wish to mix a solution that is 30% antifreeze with one that is 80% antifreeze. To obtain 20 gallons that are 45% antifreeze, how many gallons of each are needed? Okay, so this is a system of equations. We know that we have two types of antifreeze, and writing 30% as a decimal is going to be 0.3. So we're going to have 0.3x, and that's going to be the gallons of 30%. Then our gallons of 80%, we're going to call that one y. So we're going to add 0.8y, and that's going to be equal to 0.45, and we want that to be 20 gallons. So a 45% solution for 20 gallons. Now the total amount of gallons is going to come from the 30% antifreeze and the 80% antifreeze, and that's going to equal 20. Now we have to substitute this. Got to simplify a little bit and substitute it. Okay, so let's work out the 0.45 times 20. The way that I like to do this is to go ahead and move our decimal point over one time to take away this 10. So we have 4.5 times 2, and that's going to be 9. So let's rewrite this. This is going to be 0.3x plus 0.8y equals 9. And x plus y equals 20. To get rid of these decimals, we can just multiply this top equation by 10 to make our life a little bit easier. So we're going to rewrite this one more time. 3x plus 8y equals 9, and we have x plus y equals 20. I like to solve these using elimination, and the way that we do that is we have to figure out what we could multiply one or both equations by to allow a variable to cancel when we add it straight down. So I'm going to choose to multiply the bottom equation by -3, and that's going to allow our x variable to cancel. So this is going to be 3x plus 8y equals 9, and then -3x minus 3y equals -60. From here, we are just going to add them straight down. 3x minus 3x cancels. 8y minus 3y is 5y. And 9 minus 60 is going to be -51. When we divide both sides by 5, we're going to get a decimal. It's going to be y equals 10.2. Remember that y was the 80% antifreeze. So we already know 10.2 gallons of 80%. Now we just have to work out the other value. Remember that we set up an equation here, x plus y equals 20. So now we can substitute 10.2 right here and get our value for the 30% antifreeze. I'm going to work that up here. So we're going to have x plus 10.2 equals 20. Then we can subtract 10.2 from both sides of the equation, and we're going to get x equals 9.8. So we have our two answers here, 9.8 of 30%, and then we're going to have 10.2 of our 80%. That's going to yield 20 gallons of 45% antifreeze. We're going to solve 2 times the absolute value of 4x minus 3 plus 2 being greater than 14. First thing that we need to do is isolate our absolute value symbols. So we're going to subtract 2 from both sides. When we do that, we're going to get 2 times the absolute value of 4x minus 3 is greater than 12. Next, we're going to go and divide both sides of the equation by 2 of the inequality. Now we have the absolute value of 4x minus 3 is greater than 6. What this means, I always like to draw it out this way because I really think it makes more sense. The distance away, that's what absolute value means, is the distance away from 4x minus 3 is greater than 6 units. So I'm going to show you what this means on a number line. The distance away from 4x minus 3 is going to be greater than 6 units, which means that it's going to end up over here and over here. So we can set up 2 different inequalities based on what we just found out. Our first inequality is going to be 4x minus 3 is less than -6. Our second inequality is going to be 4x minus 3 is greater than positive 6. Now, you guys might be wondering why we have to have two inequalities here. Remember that when we do absolute value, the distance can go either way. So we can travel this way 6 units and this way 6 units. One is in the negative direction and one is in the positive direction, but it is still 6 units. So we have to account for both the negative and the positive version. Now we're going to solve these inequalities separately. So we can add 3 to both sides on both inequalities, and that's going to result in 4x is less than negative 3. Down here, it's going to result in 4x is greater than 9. Now we can divide the top inequality by 4 and the bottom inequality by 4. So now we end up with x is less than negative 3/4, or x is greater than 9/4. And these are our two solutions. Now we're going to write this inequality in interval form. If x can be anything less than negative 2, the way to write that is negative infinity to negative 2. And it's a parentheses versus a bracket because this is strictly less than or strictly greater than. Those are going to yield parentheses. Since this has a greater than or equal to, or we could also have a less than or equal to, that would be hard brackets. So since on this second inequality that x can be anything greater than or equal to 4, we're also going to have the solution set of 4 to positive infinity. Solve this system of equations by elimination. So if you watched the video just a few minutes ago, I did solve an equation by elimination, but we can do this again. So I can already tell that I'm going to want to eliminate my y first because we have opposite signs. And that's a good start. So we're going to multiply this second equation by 3. And that's going to allow our y's to cancel. Whenever we're choosing what number to multiply by, we have to think about what would add together so that one of the variables will cancel. So when we do that, we are going to get the result. Let's rewrite this top equation. We're going to get 6x minus 3y equals 9. When we add these straight down, 4 plus 6 is 10x. Our y's will cancel, and that's going to equal 10. When we divide both sides, we're going to get x equals 1. Now to solve for y, we would just go back and plug in 1 into either equation, it doesn't matter which one, and we'll just solve it. So our solution is going to be y equals negative 1. You also can write it like this too. Now we're going to graph this inequality. We have 4x minus 3y is greater than or equal to 24. First thing we want to do is get it in the format of y equals mx plus b. So we are going to solve this equation for y. We have negative 3y is greater than or equal to negative 4x plus 24. From here, we can divide both sides by negative 3. Don't forget, whenever we actually divide or multiply by a negative, that we have to flip our sign. So this is going to become y is less than or equal to positive 4/3 x minus 8. Now we have our y-intercept along with our slope, and we can go ahead and graph this. And I'll also walk you through how to shade it. So we're going to start at our y-intercept, which is going to be negative 8. That value is down here. Next, from there, we're going to go up 4 units and to the right 3. So our second dot is going to be right here. Now we're going to connect those dots. We're using a solid line because we have this symbol right here, which is a less than or equal to, and that yields a straight line. We would use a dotted line if it didn't have the bottom equals to there. Now, this is where a lot of students get confused. How do I shade this? I'm going to show you a game-changing way that you'll never get this wrong again. Since y is less than or equal to, we're going to ignore this part completely for just a minute. And we are going to be looking at where is y less than -8? So you're going to look here at this y-intercept, and we're going to look at the number line and see where is y less than -8. Well, y is going to be less than everywhere below it. And that's how you know where to shade. So we're going to shade to the bottom of the line all the way over. And that's going to be our solution set, is everywhere below the line. Let's work through simplifying some radicals. The instructions say simplify exact answers only. No radical can be left in the denominator, which means that we'll have to rationalize when we get there. When we're solving problems like this, I like to work it out as a factor tree. So we know that 8 and 6 multiply together to give us 48. Then we get 4 and 2, 2 and 2, and then 2 and 3. We can go ahead and cross off any factors that we have broken down because they are no longer relevant. What we're looking for, since the index out here is a 2, we're going to find pairs of numbers that simplify. Since we have two pairs of 2's, this is how the number portion of our radical is going to simplify. 2 times 2, and this guy is all alone, so it's going to be inside the radical, 3. So the square root of 48 simplifies to 4 radical 3. Now let's work on the x portions of it. This way, just for illustration purposes, I'm not going to do this every time, but this is how to think through this. Basically, the theory behind this is that we are trying to find how many groups of 2 can fit into 17 and how many x's would be left over. So we have 1 group, 2 groups, 3 groups, 4, 5, 6, 7, 8, and we have 1 x left over. That means that this would simplify to x to the 8th with 1 x left inside. We're going to do the same thing for the 9. So here you can see that we have a pair of y's, 2, 3, 4 pairs of y's, and that means that we have y to the 4th. This guy is all by itself, and that's a radical. Now we can write all of these together in one line. We are going to have everything outside of the radical, which is a 4, an x to the 8th, and a y to the 4th. And everything inside of the radical just gets multiplied together, 3xy. So this is our final answer here. Now we have the cube root of 40, x to the 8th, y to the 13th. We're going to apply the same method here. 10 times 4, 2 times 5, and 2 times 2. We're going to go ahead and cross off all of the numbers that we've already broken down. So the prime factorization is going to be 2 times 2 times 2 times 5. And you can see here that we have a group of 3 terms. Now we're looking for 3 because our index is 3. So this is going to simplify to 2 times the cube root of 5, because that one is left over. Now let's do the same thing with our x to the 8th. Remember that we are thinking how many total groups of x's can we get out of this. So if we were to write this x to the 8th 8 times, and we're looking for groups of 3, we have 2 complete groups of 3 with 2 x's left over. That means that we're going to have x times x. Then inside of our radical, we will also have x times x. So this is going to be x squared times the cube root of x squared. Let's do the same thing with the y. So when we write out 13 y's, we have 4 y's that are groups of 3 with one additional left over. So this is going to be y to the 4th times the cube root of y. Now similarly, we are going to write all of our outer terms together, multiplied together, which is going to be 2x squared y to the 4th times the cube root of 5x squared y. And that's our final answer. Now, full disclosure, we're not going to write the variables like that every time, but I wanted to give you an illustration about why it works the way it does when we go to the next step. Now we're going to do the square root of 24x to the 13th y to the 7th divided by the square root of 6xy to the 13th. Whenever we have two radicals that are divided by each other, we can go ahead and divide them underneath one radical. So what I'm going to do is rewrite this as one big radical. And this is going to help our math a lot. Okay. So 24 divided by 6 is evenly divisible. So we can just go ahead right off the bat and simplify that. That one's going to be 4. We have x to the 13th divided by x. So we're just going to subtract their exponents. That's going to be x to the 12th. Then we have y to the 7th and y to the 13th on the bottom, which means that if we subtract them, they're going to be y to the 6th, and the y to the 6th is going to be in the denominator. So let's include this under our radical and keep moving. The square root of 4 is 2. The square root of x to the 12th is evenly divisible, so we would get 6 groups of 2 x's, which is going to be x to the 6th. And then if we do the square root of y to the 6th, we would end up getting y squared, y cubed, excuse me. Okay, and then this is our final answer here. Let's practice on just numbers. So we have the square root of 18 plus the square root of 8. We can go ahead and factor this down. We have 9 and 2, 3 and 3. We have 4 and 2 and 2 and 2. Let's go ahead and cross off all the ones that we've already broken down so that we don't get confused. And we're going to circle our pairs now. So we have a pair of 3s and a pair of 2s. And both of these have an additional 2 left over. So we have 3 radical 2 plus 2 radical 2. Just to clarify, this 2 is the one that's on the outside. This 2 without a pair is on the inside. Now you can think of the radical 2's as just objects, and if we have 3 of them plus 2 of them, then we have 5 of them total. So this is our final answer. This is the part in the instructions where I was talking about needing to rationalize the denominator. Because we're not allowed to have radicals in the denominator, what we're going to do is multiply the top and the bottom by a radical that's going to get our denominator to cancel. So what we do is we are going to multiply this guy by the square root of 5. By doing that, we're going to get a whole number in the bottom. And we can go ahead and distribute this to both terms. So we're going to get 3 radical 5 plus radical 5 times radical 5, which we'll simplify in a second, over radical 5 times radical 5. 3 radical 5 cannot be simplified any further, but these two can. The square root of 25 is 5. So our final answer is going to be 3 radical 5 plus 5 over 5. Here we have two bases that are being multiplied. So the x's are actually being multiplied here. So but that means we're going to add their exponents. So this is going to be x to the 2/5 times x to the 18/5, or x to the 2/5 plus 18/5, and that's going to be x to the 20/5, or x to the 4th. And that's our final answer. To start this one, we're going to distribute our radical 3. So we're going to have 5 radical 3 minus 2 times radical 9, or 5 radical 3 minus 2 times 3, so 5 radical 3 minus 6. Here, we're going to distribute our first term to both terms in the second set of parentheses, and then we're going to distribute the second term to both terms in the second set of parentheses. So this is going to be the square root of 9 plus 7 radical 3 plus radical 3 plus 7. And if we have 7 radical 3's and we are adding 1 to it, that means we're going to have 8 radical 3's. So this is going to simplify to 8 radical 3. The square root of 9 is 3, and we can just go ahead and add the 7 and the 3 together to get 10 plus 8 radical 3. When adding fractions, we still have to get a common denominator, so we can multiply this equation or this expression by 3 over 3, and we can multiply this expression by 2 over 2 because we're looking for a common denominator between 3 and 2, and that's going to be 6. So 2 times 5 radical 2 is 10 radical 2, plus 3 times radical 2 is 3 radical 2 over 6. And if we have 10 radical 2's and we are adding 3 radical 2's to that, we're just going to have 13 radical 2 over 6. Here we have a negative radical, so it's going to be the square root of negative 50. We're going to break this down into 25 times 2 and then 5 times 5. We'll cross off the ones that we've already broken down, and we'll deal with the negative in a minute. Since the index out here is 2, we're going to be looking for groups of 2 numbers. So we have a 5 that's going to come out of the radical, and we're still going to have the negative 1 and a 2 on the inside. Now, you may recall that the square root of negative 1 has something specific that it simplifies to. Okay, and this is going to be the number I. It's a complex root. So we're going to have 5i radical 2 here. We're going to go ahead and distribute the same way, first term to both, second term to both, and then combine like terms. 4 times 9 is 36. 4 times negative 2i is negative 8i. Negative 3i times 9 is negative 27i. And negative 3i times negative 2i is positive 6i squared. These two terms combined together is going to be negative 35i. I squared is negative 1, so we're going to replace that with negative 1. So we can combine our positive 36 with our negative 6. So our final answer is going to be 30 minus 35i. When subtracting these, the important thing where a lot of students make mistakes is they forget to distribute the negative to both terms in the second set of parentheses. So this is going to be 5 minus 2i minus 3 plus 9i. Our like terms are our 5 and our negative 3 and our negative 2i and our positive 9i. So we're going to get 2 plus 7i. 2 divided by 3 plus 5i. Here we have to multiply by the complex conjugate. All that is the denominator with a switched sign in the middle. None of the other signs get changed. This, you might notice from earlier, is a difference of squares. So this is always going to factor to a squared minus b squared. Now let's distribute this 2 to both terms. We're going to get 6 minus 10i over 3 squared minus 5i squared. So we're going to have 6 minus 10i over 9 minus 25i squared. 6 minus 10i over 9 minus 25 times negative 1. 6 minus 10i over 9 plus 25. So we have 6 minus 10i over 34. And technically, you are supposed to separate the real from the imaginary parts. So this is going to be 6 over 34 minus 10 over 34i, which then we will simplify down. Both of these are all divisible by 2. So we're going to have 3 over 17 minus 5 over 17i. And this is your final answer. This is solving a radical equation. When you're solving these, you have to think about the opposite sign or the opposite, how to cancel out a radical. Since we have an index of 2 here, we are going to square both sides. So we're going to end up with 4x minus 6 because a square root and a square are inverses of each other. They're going to cancel. So 4x minus 6 is going to equal 9. We're going to add 6 to both sides. So it's going to be 4x equals 15. Then divide both sides by 4. So we're going to end up with a final answer of x equals 15/4. This is a quadratic equation, and the first way that I would try to solve it would be by factoring. Since factoring doesn't work, we are going to have to use the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, and the entire thing is over 2a. Our b term is going to be this middle term here. Our c term is going to be this last term here. And then our a term is going to be the number in front of our x squared term. So here's where we plug everything in. X equals, negative is a part of the formula, and b is also negative 2, plus or minus the square root. Again, b is negative, so we're going to go ahead and plug that in that way. Minus 4 times a is 2, c is negative 5. Then we have it all over 2 times 2. So we're going to simplify this. Negative times a negative 2 is a positive 2, plus or minus the square root of negative 2 squared is positive 4. Negative 4 times 2 times negative 5 is going to be positive 40. All over 4. So x equals 2 plus or minus the square root of 44 over 4. We can simplify this just a little bit. If we do a factor tree for 44, we're going to have 4 times 11 and 2 times 2. We can cross out the numbers above, and we have a pair of 2's that are going to be able to come out of the radical. So x is going to be equal to 2 plus or minus 2 radical 11 over 4. We're almost done. All of the coefficients and numbers out front are all divisible by 2. So when we divide them all by 2, this is what we're going to get for our final answer. And this is the last one. So if you've watched this far, congratulations, you have finished an entire review. So here we go. Similarly to problem number 31, where we had to square a square root, this time we are going to have to take the square root because we are starting off with a squared term. So what this problem is going to become is 4x plus 5 equals plus or minus the square root of 3. Anytime you take the square root, you want to make sure that you include your plus or minus. Now we can go ahead and subtract 5 from both sides, which is going to be 4x equals negative 5 plus or minus the square root of 3. Now we can divide both sides by 4, And that's going to be our final answer. Thank you so much for hanging in here with me. I'm so thankful for your support. Make sure you go ahead and click subscribe on my channel so that I can do more things like this and help more students out in their math classes.